I'm Evelyn Lee.
And I'm Janine Chastain. We're collaborating on curated conversations to explore how the industry of architecture is changing.
Together, we'll find ways to create new solutions to current challenges while elevating the value of architects.
Welcome to Practice Disrupted.
Hello, listeners. Hello, Janine.
Hi, Evelyn. Hi, Disruptors.
So while I previously knew of today's guest through her TED Talk, How to Build for Human Life on Mars, I had the honor of meeting Melodie Yashar and introducing her at this year's AIA's Women's Leadership Summit as one of our keynote speakers. And I have to say that following your keynote, by the way, all I heard was that was the best keynote of the entire event. So you really did leave an impression. And I've spoken at a few events since then, and I talk about you as an outlier in our field. And people are like, they're still referencing the keynote. They're like, oh, she was so great. I got to see her at Women's Leadership Summit too. So you've really made an impact.
Oh, wow. Thank you. That's such a wonderful thing to hear.
High praise. I'm excited too. I've heard about this topic floating around the AIA, but I haven't heard about it specifically. So today is going to be first time for me, and I didn't even know how to prep for this. But Melodie Yashar is a space architect, technologist, and researcher. She's the vice president of building, design, and performance at Icon, a construction technologies company focused on large-scale additive manufacturing. Melodie oversees the architectural direction of Icon's built work, as well as the performance of Icon's building systems to deliver optimally performing structures that shift the paradigm of home building on Earth and in space. We are excited to understand what that means. So maybe let's jump into, I just want to know what a space architect is. Can you define that for us?
Of course. It's such a good question. I mean, yeah, it's true. How not only do we in architecture think about spatial design, but then on top of that, there's this added dimension of thinking about off-world environments, extraterrestrial environments. A space architect is essentially someone who is envisioning habitats that can support humans on an extraterrestrial body or in orbit somewhere outside of our own world. There's a small but thriving community of space architects globally who practice in both architecture terrestrially, but also thinking about off-world systems. So there's a niche of space architects within the aerospace sector, which is growing steadily. We have space architects at Blue Origin, Axiom, Sierra Nevada, at NASA. And it's definitely a niche discipline, but one that's gaining a lot of steam, particularly as the viability of having humans live off-world and be off-world is becoming more and more real year by year. So it's an exciting time to be a space architect for sure.
Can I ask a clarifying question? Is a space architect, do you differentiate the spaces that you design separately from those who are working on the spatial design of the rocket ship, for example? Is that different?
It's a really good question. So I think one of the key tenets of being a space architect, if I may say so, is that there really is not a generalist kind of integrator, considering the needs of astronauts and people in space, considering the needs from, the mass and payload side of things, which generally is the area of a systems engineer or a rocket propulsion engineer. There's not somebody looking at this holistically as far as human experience is concerned, because that tends not to be an engineering discipline or subject matter, right? So a space architect can add so much value, not only in coordinating all of these in the same way that a terrestrial architect would, coordinating other engineering disciplines and making sure that you're not compromising the needs of a person or an inhabitant for their most fundamental needs.
I way jumped the gun on this interview because my husband and I are both really into space and NASA and all of the great things. We watch a lot of the launches in our free time. So I should maybe take a step back and just, we typically ask our guests to tell us something about themselves. Is there anything else that you want to add to your bio that we didn't mention?
No, thank you for the wonderful introduction. That was so great. I am really lucky. I never really thought that I would be working both on conventional architecture and outer space architecture at any point in my career. And it's kind of a miracle to me that I'm able to do both in the work that I'm doing at Icon, which is, neither a full aerospace company nor a full architecture practice. It's a technology provider and a technology developer. So it's been a really interesting kind of career trajectory, leaving architecture in the traditional sense and then making a move to think exclusively about aerospace and study basically, in my tenure at NASA. And now it's all come full circle, and I'm working in both architecture and construction and thinking about off-world systems. So it's been a really wild ride, and I feel really, really happy and really excited that I've been able to contribute to so many of these areas at once.
I think it was just really kind of exciting that you actually have to differentiate between terrestrial architecture and any other type of, that's a world that those two words exist together that I don't think I ever would have thought would have existed in my lifetime anyways. My 8-year-old son very much wants to be an astronaut growing up. So it's good to know that we're already planning for the type of accommodations that he will have in his future life, both getting off-world and what those living environments might look like for him if he continues along this path. So you mentioned that the field of architecture isn't that big. And obviously this field of space architecture is rather niche. The field of architecture is looking very multidisciplinary. So when you think about the people that are serving with you, or that would also call them space architects, do they have a similar traditional architecture background, or are they coming at it from even a more multidisciplinary perspective?
It's such a great question. So I'm a member of the AIAA, which is the American Institute of Aeronautics and Astronautics, which is notably similar to AIA as an acronym, but in any event, it's the AIAA Space Architecture Technical Committee. I'm going to be the vice chair of that technical subcommittee this coming year. By and large, the members come from traditional architecture disciplines. And so either is someone who's been an architect, who has an architecture practice and has pursued space architecture on the side, or someone who has, like me, made a jump in their research trajectory. Like I went back to school, studied human-computer interaction and robotics, and then I made a very deliberate decision to focus on space systems. So you do find people who decide, I want to go full on into aerospace, and then they make that interdisciplinary jump and then somehow manage to bring all of their architecture skill sets and talents to the table in whatever new position they take on, which I have found to be extremely fascinating, particularly in the aerospace domain. Like you don't have engineers who have the visualization skills of an architect. And so it tends to be a huge value add. It tends to be a kind of unifying, let's say, gesture to really get people on board and have buy-in and sign off on a complex idea that you can understand in an image visually within 5 seconds, but not within, a 30-page engineering report. So it's been tremendously helpful in galvanizing big concepts and integrating and synthesizing opinion on these like very large, what I would consider to be mega projects when it comes to space. But yeah, other than that, folks who are in the AIA technical subcommittee, a wide range of academics, professional practitioners, people who are only working on terrestrial architecture, whether it be the design of spaceports, exhibitions, and other kind of remote and extreme environments here on Earth and terrestrially, and folks who have made the full jump into aerospace and who are working either with a private aerospace company or who are in-house at NASA.
When you expressed interest in this area for your career, were there mentors, or did you figure this out for yourself? Or did they just look at you like, she's crazy. Like, I don't know how to advise her, and good luck. Like, how did you figure out where that community existed?
It's such a good question, because I was not aware of the space architecture subcommittee until much later. Now, once I had already sort of been engaged in one or two space architecture projects, but I came into this discipline pretty serendipitously. Like, a group of former grad students and colleagues of mine from grad school and myself got together on nights and weekends and submitted to NASA's 3D printed habitat competition way back in 2014, 2015. And we won that competition, which was a big surprise for us. And basically, we started to receive phone calls. Like, we started to gain recognition in what we had no idea was this new field and this new discipline. And private aerospace companies reached out to us. And over time, I started to learn about the lineage of space architects who were part of the subcommittee and who were in and out of NASA and other companies. And that's where I gained some very, very valuable mentors, all of whom are still my teachers and my friends today and my colleagues today. And they have been instrumental in the work that I've been doing ever since.
Was that an unpaid competition that you guys entered?
Yeah.
It's one of those unpaid design competitions.
Totally. It was volunteer based. There was no guarantee of winning compensation at all. It was like a straight up passion project that we were doing on nights and weekends. And you think about how closely that resembles architecture and architectural competitions. I still, on the one hand, I can really tell a success story for how powerful the competition was, but I'm also just one person, and our team was one of hundreds, if not thousands, that did not succeed, right? It's very strategic to crowdsource ideas from the general public, because you really are it's the best and most, let's say, lucrative way to get a wide variety, a great diversity of responses to a critical problem in a short amount of time. But not compensating groups, particularly student groups or young professionals, is I realize the problem there, and I realize the conflict inherent in that. Fortunately for us, we would have done the work anyways, and it was something that fueled the rest of our trajectories as space architects, but also it introduced a portfolio project that was invaluable at the time. Yeah, so it was definitely, I would say the work that I started as a space architect was a product of the competition and not knowing where it would go from there.
What was it that got you excited about this niche? Like, why choose this field?
It was really a problem that represented to me a confluence of what's possible between design and technology. And at the time, I was working in New York in particular in a pretty normative hospitality focused practice. I was pretty disillusioned with the status and the nature of architecture that I was doing there. I thought that the kind of glacial pace and the degree of coordination that we were doing and the status of documentation relative to architecture that we were involved in was pretty archaic, and I found it uninspiring. And again, I always knew that there had to be ways of introducing a higher level of technology development through design and through architecture, but I wasn't sure how to do that or where to start, right? So when the competition came along and I saw it was about 3D printing, which was an area that I was extremely fascinated in just from the prototyping side of things, it felt like it was one way of not only advancing my knowledge in the technology and taking it beyond just, the scope of creating an architectural model, but on top of that, like tackling the most challenging scientific and technological problem of space, right? And how you can sort of merge architecture with a specific idea or opinion of space robotics. So that was the thing that really compelled me at the time, and it still does, frankly. Like all of these problems, all of these like let's say problem spaces are the ones that I'm still so motivated to make a contribution to.
It's interesting hearing about that side of things for you, and then looking at the microcosm that is space architecture and the idea that it's also an opportunity to kind of rebuild a new architecture profession from the ground up in a much more collaborative way. Do you find that it is much more hopefully collaborative than kind of the normative hospitality firm that you left? Like beyond it's cool what you're doing, is it also a better working environment that you find yourself in?
I think that Icon is a wonderful case in point for how you can reimagine the role of architecture to radically rethink not only design processes, but also construction processes. I don't know if the discipline of space architecture is there yet. I have to say, like, the real value that I've found in space architecture has been in setting a grand vision for the future and to really galvanize and gain the buy-in of aerospace stakeholders who may not necessarily believe 100% in what's possible. But in my experience, it's been the architecture proposals, and particularly the schematic and the conceptual design proposals that we've done, which have really accelerated folks on the engineering side, and particularly at NASA, to gather around and accelerate the technology development to support the vision of a permanent human presence in space, which is, not something that you would expect to happen, but it's kind of like you see it to believe it. Like suddenly you see this incredibly inspiring vision of what future life could be in space, and people are really excited about it. Like they start to think that it could be real. And so it's really that kind of like synthesizing, galvanizing quality, which has been so lucrative for us in space architecture. In the more short term, I think that my team at Icon and the work that we're doing at Icon is putting a really sharp focus on the way that design process happens, because not only do we work in construction, but in addition to being a technology developer, but we also do in-house design. So there's lots of stuff in the short term that our team really optimizes as far as the design process is concerned when we're thinking about 3D printed buildings that introduce a new perspective to what architecture is and what it could be. For example, we have a very distinct idea of design build, which I think is unique from others in industry. In particular, we know our system best. And so we have introduced lots of efficiencies and optimizations relative to how we design our wall systems, how we introduce building enclosure, how we integrate with roof and foundation systems, which only we know, like we have a specific subject matter expertise for. And because of that, we're able to introduce new design ideas and introduce new architectural opportunities that, frankly, others would probably have a pretty long kind of learning curve to introduce. So because we have this design language and our details figured out, we're able to accelerate design timelines far, far faster and introduce new design, let's say, features and elements that have never been seen in 3D printing before in ways that have been really exciting to witness.
Are you able to talk about some of the projects that you've been able to work on and design? I don't know if there's a confidentiality issue.
No, yeah, sure. One thing, so I'll give a couple of examples. We're currently in construction on a development just north of Austin called Wolf Ranch. This is the largest community of 3D printed houses in existence. We basically brought the Bjarke Ingels Group to the table as the designer of the project to collaborate with Lennar, who is a production scale home builder. And we knew that this was a collaboration that would never have been facilitated if we did not initiate the two to work together, right? And so there was this tension in the sense that the Bjarke Ingels Group was not necessarily aligned in every step of the way with the general kind of production scale or the general, production scale approach that Lennar takes to home building, and vice versa, right? Like Lennar was not used to the kind of care, attention, and development timeline that Big was in developing new ideas, details, introducing new materials to the process. So via that collaboration, as well as our general design to print, let's say, process or protocol, we were able to realize the project with the two working hand in hand and introduce new design ideas while still adhering to a very, very accelerated design timeline that Lennar was asking us to pursue.
So obviously you brokered that partnership, but then what becomes your ongoing role in the relationship between those two and how that product gets, or the project gets implemented then?
It's such a good question. So I'll talk a little bit about what architecture is at Icon and what we do and how our team is really split up. There's 5 main areas that we contribute to. One is construction architecture, which is the implementation of new details, identifying products that work best with our system, coordinating general design consultants, and basically managing the scope of the project in addition to any new features and elements that we've never realized in the field before. So construction architects also initiate mock-ups of new conditions, which is a lot of fun. And if there's any kind of, let's say, technology development initiative that we have, like pursuing a higher overhang or cantilever in the geometry, this is something that we coordinate on the technology side ourselves. So one of the things that we're pursuing actively right now is how to create arches, domes, and vaulted geometries, which have historically been pretty difficult to do using additive manufacturing and 3D printing. Our design team is the one who coordinates with our software, hardware, material science teams to actually realize those new geometries and introduce those new applications. Other groups within architecture Icon design technology. So we have a number of design technologists, which essentially translate the design intent from the drawings into functional G code and a tool path that the printer follows. So it's largely a software coordination and integration effort. We have a building science and building performance team, which analyzes built work in addition to running simulations and making recommendations from a building performance perspective and a weatherization perspective for how our upcoming work and designs should be performing or how they should be modified. And we also have in-house structural engineering. We've realized that one of the ways to really expedite design processes and coordination efforts is to be sure that design and engineering are working hand in hand. So we're not designing separate from or ignorant of how our wall system is engineered. And we've been able to implement and create a number of engineering design guidelines, which we're hoping are going to be helpful and productive for advancing the state of the art in industry so that others can design 3D printed wall systems as well. And then lastly, regulatory affairs. So we manage the stakeholder relations of Icon as well as our other consultants when we're working or building in new jurisdictions that we never have before, or with other regulatory bodies, code committees, and councils and subcommittees who are not familiar with 3D printing or who've never worked with us before. And we manage those relationships and provide them the information that they need. Yeah, so we're not
always in the driver's seat on design, but we are the ones who are actually realizing the design from a traditional CAD environment or Revit environment into what's printed in the field. And slowly but surely, we're doing more in-house design as we speak. And we're excited to really ramp up that capability. And, it's been interesting we've started out historically working with more design consultants. And now that we have a very robust team developed and, we've printed so many projects, over 100 structures to date, we have a better sense of our system and the design possibilities implicit for our system. So I'm really excited we're doing more in-house design.
One of the projects that some of our listeners might be most familiar with is House Zero, which was built in Austin, Texas. And so I think that was a collaboration with Lake Flato, correct?
Yes, that's correct.
It's a beautiful project. I got to see it last year when Evelyn and I were in Austin. My husband and I went and toured it. Well, we didn't get inside. We were on the outside walking around. I'm sure that the people that live in that house are probably starting to get tired of architects walking around the perimeter of their street, but it's such a beautiful project. And it's so well done with bringing those two primary materials together, the wood, and I don't know what the 3D printed material is. What is that?
It's a mortar-based cement material. We refer to it as lavacrete. We have like a lava volcano theme going on with our systems.
Yeah, it's a beautiful one. And I'm sure that you all are starting to get into even more experimental design with the shapes that you can configure on the exterior facade.
Definitely. We're really interested and are actively investigating how we can introduce those undulating forms and more amorphous and eccentric parametric geometries using 3D printing, because that's really that's the value add of the system as compared with cast in place concrete or masonry or other forms of construction, is that we have this incredible design freedom to model something digitally and be able to realize it in a free-form way using the 3D printer without added formwork and without additional cost. So for us, there's effectively no difference. The nozzle is pretty agnostic to whether it's printing a straight line for a vertical wall or something which is three-dimensional and eccentric and interesting, right, from a visual perspective. So we try to play into that and introduce those opportunities whenever it's appropriate, and whether, assuming that it's the right move for the project.
I am struggling in my head with the duality between some of the more prominent 3D printed villages, whether through Icon Technologies or other individuals, are focused on affordable housing and what that means. But the technology that Icon has is so incredibly specific. So in my head, I'm thinking like, well, but then how do we scale that? So is there a world ever where I, as an architect, as a firm owner, could own a piece of Icon technology? Or is the plan always going to be kind of, you guys are the purveyor of the technology and thus the deliverer of that system?
There may be a future in which the technology is put into the hands of builders and designers. We're not at that point yet. I think it would be wildly exciting for that to happen, but we are really, really interested in collaborating with more architects today and introducing as diverse and a vision of future housing, particularly large developments and affordable housing, as we can. In fact, we have a design competition, oddly enough, that we've introduced and that we've announced. It is currently receiving applications, and it is referred to as Initiative 99. This is our solicitation for students and professionals to design an affordable affordable 3D printed home using Icon's technology for under $99,000. And the thing that's unique about this competition, unlike others, within the architectural profession, is that we're making a commitment and a promise to build and realize one or more of the winning designs. And that will be within one of our partner communities, either within the Austin area or internationally. So we definitely encourage you to take a look at this competition and submit it. The website for the competition is initiative99.com, and we are receiving submissions from until December 8th. So it's coming up pretty quick.
I kind of want to make the jump back to space architecture because I feel like I still have more questions there. I guess now understanding that you're doing this 3D printing here on Earth, what are some of the types of projects that you've been able to design at a schematic level for space?
Oh, yeah, definitely. So I'll say this, that the NASA group, which Icon collaborates with and who is really Icon's client most frequently, is known as the Moon to Mars Planetary Autonomous Construction Technologies Project or Program, let's say. It's MPACT for short. Essentially, we have been working with this NASA group to reimagine what infrastructure on the moon might look like within the next 10 to 20 years. And so we know that we're going to start with some pretty basic civic infrastructure and civil engineering types of structures, starting with horizontal types of construction. So things like landing pads, roads, flat types of civic infrastructure. And then eventually we'll build upwards and go vertical and introduce things like blast shields and berms and unpressurized hangar buildings, garages, really unsexy, unexciting civic kind of structures. And the hope is that we will advance the technology and advance the maturity of all of the systems that we deploy into space enough so that eventually we can think about and build pressurized habitats that are certified for human occupancy. And we're hoping that those types of structures will support small crews to begin with, whether it be from NASA or others within the commercial sector. And then eventually, the type and scale of structures that we introduce for people will grow and expand into small settlements, or a small base camp, I should say, rather, and introduce a wider diversity of types of structures and applications, thinking about things like greenhouses, for example, or other types of structures that can really support a full and robust scope for human life in space. Let's say that.
So obviously podcasting is an audio platform. So for individuals that aren't necessarily drawing the line between 3D printing and being a space architect and the automation, can you help do that for our listeners and why 3D printing and then space architect goes together?
Yeah, absolutely. NASA has been interested in developing large-scale, large, robust, and durable structures that can protect people in the extreme and hostile environment of space for many, many decades. And so the question became, how are we going to introduce these large structures in space when it's prohibitively expensive to send very, very heavy materials like concrete by the ton into space? Like, we can hardly send small payloads to the surface of the moon in an affordable and sustainable way, let alone tons and tons of cementitious materials to create infrastructure for a small base. So one of the leading ideas has been, well, why not send a single additive manufacturing robot or a small 3D printer that can basically be sent up there and use the local and indigenous dirt on the surface of the moon and eventually Mars. So use local and indigenous regolith, which is what the dirt is referred to, and 3D print structures using that material rather than bringing systems and bringing construction materials from Earth. So this has been a prevailing idea in research for, like I said, many, many decades. And it's there's an incredible value add, because in theory, you can just send one construction robot rather than multiple to create a wide variety of infrastructure, starting from the landing pads and roads I mentioned, and then eventually, hopefully, building those pressurized habitats for humans. And so that's been the idea, is that we want to introduce a single robotic system that can deliver a wide range of civic infrastructure.
And I think that even the next level of that too is that it can all be autonomous. So you could essentially have all of this infrastructure built before the first person actually sets foot on Mars.
Yes, exactly. It gets even harder when we think about the challenges of a Mars mission. For the time being, we're supporting the Artemis missions, which are all focused around developing this initial infrastructure at the south pole of the moon. The moon is a lot easier to get to, and a lot safer too, frankly. If you need to evacuate and go back home from a lunar mission, like, we're talking about something on the order of 2 to 3 days. But if you're on a Mars mission, you don't have any there's no potential for evacuating and coming back home. Like, you are going there and you're going to be staying on the surface of Mars for however long your surface operation will take. That ranges from 1 year to 500 days. And then you have to wait for your orbital rendezvous to be exactly right so that you can hitch your ride back, which would be another 6 to 8 months. So it's incredibly challenging to imagine construction operations for a Mars mission. And so one of the things that we're really interested in is, just as you said, Evelyn, developing autonomous capabilities so that when we do send robots to Mars, they're able to have decision-making capabilities and independence to actually realize these structures without the need for human intervention.
I have a couple follow-up questions. One, we spend so much time here on Earth thinking about regulation in terms of what we're able to design. I'm imagining that the regulations that you all are designing around are pretty significant. And I wonder, how that comes into play, how NASA's been able to, maybe it's coming from NASA, I don't know, provide that direction, if it's coming from engineers helping with that. I think the question in this is about prototyping. How do you plan for things that you haven't experienced yet? And then also, how will they prototype at some point?
It's such a good question. It's still early when it comes to the in-space structures that we're designing. We haven't determined the factors of safety for a 3D printed structure in space that would house humans. We're still in the early stages, I would say, early, but also technologically pretty advanced stages of developing the materials and the applications for the 3D printing technology in space, but not at the point where we can say that we've identified the structural needs and requirements of what a lunar structure might be, just because there's so many open questions relative to the soil conditions, the seismic conditions. We don't know where we're landing or when, and there's so many variables that go into structural design for the moon. As far as the regulatory environment here on Earth, even still, 3D printing is considered an emerging technology. So there's no official building code within the IBC for 3D printed technology. And what's happened instead is that councils and groups, regulatory bodies like ICC, have developed an evaluation service where you can essentially introduce all of your testing data and all of your engineering work and guidelines relative to 3D printed wall systems. And using their evaluation service, you can comply with their criteria. So we're excited that we comply with the AC 509 criteria that was developed by ICCES. And there are other certifications that we're pursuing as well to really introduce confidence in our system, and also to print in multiple jurisdictions nationally and hopefully internationally in the future.
Do you all have a running list of pop culture space infrastructure that you all think is premier or like exemplary? Does that ever come up? Is that a conversation you guys talk about?
It's a really interesting question. So, one of the things that's so interesting about the commercial landscape today in aerospace is that you have these major giants, Blue Origin, which is Jeff Bezos's company, and then SpaceX, which is Elon Musk's company. And each has a very unique idea of what developing the moon and Mars might look like, right? And none of those visions tend to be, of course, like they're extremely, let's just be honest, they're extremely masculinist. They tend to be very kind of colonialist in the way that they imagine settlement and the way that they imagine civilization sort of unfurling from everything that they implement. It tends not to be very inclusive. It tends not to factor in the needs of stakeholders from the nonprofit sector and from folks who are not collaborating and who are not part of this giant monopoly for space development and exploration. So one of the things that I have really loved thinking about are kind of thinking ahead to a future in which you have designers and architects who are really at the forefront of envisioning this future life in space and imagining what a really participatory master planning and urban development process might be like. Because really, like, it seems so far-fetched, but the lunar surface is like a totally blank slate. And a lot of private companies see that as a way of building faster and basically extracting resources for profit, for commercial gain. And yet there's so much more at play there when it comes to thinking about planetary protection, when it comes to indigenous land use, that has not made its way into most of the discussions that I've heard from NASA and from others who are so interested in lunar infrastructure development. I think it's such an incredible opportunity for architects in particular and designers in particular to really get involved and incorporate their thinking and incorporate their knowledge and knowledge base as generalists when it comes to urban development, land development, and thinking about communities and how small cities develop. It's something that, like, I didn't know I would be able to provide insight in, but being a designer and architect, that's like one of those emerging areas where I was like, wow, like there's so much room for disruption here, and it's so ripe for a new perspective. And hopefully we'll have others involved in this as time goes on. And I do think it's important to stress that this is such a new field, space architecture and thinking about development in space. There's certainly room for others to get involved and for others to be active in thinking about what this new future might be. I teach at Art Center College of Design. And when my students are starting out in space architecture, very frequently they cite examples from popular culture. Like, what about the Nat Geo series Mars? Or what about the movie The Martian? That comes up a lot, right? Like, how reliable is that? Can we refer to that? What about the look and feel? Is this accurate? And it really puts a pinpoint on the reality, which is that popular culture is always influential to broader ideas of not only architecture and design, but what future life in space might be like. And so it's kind of like you have to respond to what exists because it's just a part of the of general consciousness at this point. There's an old rumor that back in the Apollo era, that some of the NASA engineers that were designing user interfaces were actually looking to Star Trek to get started. And yeah, it's a mistake to think that we're not going to be influenced by these images and the ideas that float around in popular culture. And I think that if anything, it's something to respond to and something to consider before we embark on a design process.
Okay, of a more pragmatic nature. So my husband, who's an architect, wants to know what are the structural limits of lavacrete, and also can it work with rebar?
Oh, yes. I'll start with the rebar question first. So we have extensive testing data supporting compressive, flexural, and in-plane shear strength, and there is definitely rebar within our wall assemblies. We include multiple types, so horizontal, vertical, as well as lateral reinforcement within the wall. And yeah, the one thing that I'll say is that unlike a kind of monolithic wall system that you get or that you assume a cast in place concrete wall might be, what we do using the lavacrete material in our printing system, which is referred to as the Vulcan, is we introduce a wall assembly. And so we have multiple wall systems that are created using the tool path of the printer. And via that tool path, we're able to introduce structural cores from within which we have vertical reinforcement as well as grouting, and as well as a air cavity within which we have insulation that we place. And then, of course, on the exterior of the wall, we have the option to put block filler and paint the walls, which is something our customers are interested in certain instances. We're really creating a wall assembly using the toolpath of the printer. It's not like the material is the wall system itself.
He also wanted to know, he said the sustainability of concrete depends largely on the content of its mixture. And it looks like you all have a plant where you are able, well, actually, it's like portable. You're able to bring the process to site to mix the lavacrete. And he wanted to know, would you ever consider working with local plants to produce lavacrete to expedite the process or lower its cost?
Oh yeah, absolutely. That's definitely something that we're interested in, and we also have ongoing research investigating how to use local materials when it comes to engineering our mix. So yes, these are all active areas of research, definitely.
So if there's anyone that's listening into this conversation and like, oh, I really want to get into space architecture, how fast is this field growing and what are the needs for more architects in this area?
I think it's growing very rapidly. And every so often, when I first got started, it really felt like architects who worked in aerospace were just focusing on terrestrial facilities. So I mentioned like spaceports. Virgin Galactic had a number of architects working with them at the time. But now that we have more, there's this growing interest in low Earth orbit and introducing a new commercial space station, multiple new commercial space stations in low Earth orbit. There are lots of architects in the aerospace sector who are working at Blue Origin on the Orbital Reef project, at Axiom, at Sierra Nevada. And so it feels more real than ever. And the discipline is certainly growing, and I know that that's not going to stop anytime soon. That's for sure. I would say too that prototyping this work is extremely difficult. So there's lots of applications, and something that I really try to promote in the work that we're doing are that there's lots of applications to prototype and introduce near short-term test beds here on Earth to prototype these ideas for space architecture even before they go to space. And those ideas might have more to do with like environmental control. They might have to do with how we can introduce advanced food systems like greenhouses in space. But testing those ideas and implementing them in research in the short term here on Earth. At Icon, we've been really lucky to have contributed to the design and construction of the CHAPEA analog, which is an analog experiment at the Johnson Space Center in Houston, Texas. And that experiment is all about introducing, well, basically, there's 4 crew members locked up in this structure. They've been there. Ingress for the experiment started in June. And we're so excited to see what the results of this experiment will be, because it will actually advance the viability of a lot of the systems that they introduced on the inside of this Habitat for Space, and hopefully set some long-term standards and requirements and guidelines based off of what they learn. Yeah.
So you mentioned, if we can't go into the field of architecture, that you guys are actively working with other architects. So I imagine there might be some limitations right now of jurisdictions that you've already gotten approval. But if other architects are wanting to explore these tools with you, what's the best way for them to do so with Icon?
Oh, absolutely. Should reach out to us at Icon. We're so interested in working with architects nationally and globally to introduce a new perspective to 3D printing. We really see it as a new design language, and what's possible using 3D printing is something that we're only going to be able to do. We're limited in doing on our own. And so we want to bring as many voices and visions to the table as we can. So definitely reach out to us at Icon. We would love to hear from you.
Hi, Disruptors! If you like the content from today's show, you can find all of our past episodes over on practiceofarchitecture.com/podcast.
Be a part of the conversation by joining us, our speakers, and others in the community at practiceofarchitecture.com/community.
Our social media handle is Practice of Arch. That's Practice of ARCH. We'd love to hear from you, so feel free to drop us a DM and say hello.
Thank you for joining us on Practice Disrupted, a podcast by the Practice of Architecture. Tune in next week for a new conversation on change in the profession.